In the name of God. Hello, guys. Welcome back to Ferho's website. My name is Masood. I'm a physics teacher. We are going to explain new subject, and we want to start the new section from grade 11, section 1-3, falling objects. The first subject that we want to talk about is free fall. Let me read the definition of free fall, and I'll break it down for you. So, what's the free fall? The motion of a body under the only action of its weight, neglecting air resistance and any other force. Right, so the motion of body under the action of only one force, and this force is uh, here, your book mentions under the action of its weight. It means under the action of gravity. Only gravity of the planet acts on the falling object. Actually, free fall is not uh, just for Earth. Actually, this phenomenon is taking place above the surface of any planet or any moon. Uh, it's a general concept, right? Uh, and near the surface of any planet or celestial object, uh, actually only gravity of the planet acts on the object. That's why near the surface of planet actually is considered the motion is considered to be free fall, right? But at high altitude, uh, the motion of falling objects, is not considered a free fall because at high altitudes, some retarding forces are present, like air resistance. That's why air resistance uh, actually uh, uh, has an effect on the falling object. And in this case, there are more than one force. There are more than I can say beside gravity, there is another force that acts on an object, and that's why we cannot consider the motion of objects at high altitude, let's say, as uh, we cannot consider them free fall, right? Think about, for example, parachutist. The motion of parachutist and its parachute is not considered free fall because at high altitude, uh, the parachutist falls down, and air resistance has a significant effect on the motion of the object, on the motion of the parachutist and the parachute. That's why, and the motion of the balloon itself, motion of the balloon uh, is not considered actually free fall because of existing air resistance beside gravity. So keep in mind that only gravity actually is in charge of free fall. If there is another force beside gravity, the motion is not considered to be a free fall. Right. I'm gonna make it easy for you. Free fall is a vertical motion of any object, whether the object is actually moving up or falling down. Let me give an example for you. Actually, there's a tennis ball. Right now, this tennis ball, I'm gonna throw it up. Right. Whenever you throw the ball up, so uh, the object or the ball is in free fall. Right. Whenever you release it down, whenever you fall it down, the object is considered free fall as well. So any vertical motion near the surface of planet, whether the motion is going up or falling down, is considered free fall, right? Uh, this is an introduction of free fall in general. Uh, I I prepared some tips for you. Let me read the uh, I prepared two tips for you. Let me read them for you. Tip: free fall is taking place when two conditions are satisfied. So on two conditions, free fall is taking place. The first condition is near the surface of planet. If the motion is taking place near the surface of planet, this is the main condition. Whenever I say near the surface of planet, means we neglected air resistance. We neglected retarding forces like friction, like air resistance, right? So near the surface of planet, that's the first condition. The second condition, in the absence of air resistance, in the absence of air resistance, or in the presence of only gravity, in the presence of only gravity, or in the absence of air resistance. If you take a look at the note at tip number 2, I didn't mention, for example, gravitational force of Earth, because I told you free fall is not dedicated only for Earth. Uh, maybe you, maybe an astronaut like David Scott in 1971, maybe did an astronaut does an makes an experiment above the surface of moon, above the surface of any planet like Mars. In the future, maybe some experiments will take place over the surface of any planet. So what do I mean by this? I'm gonna tell you that the free fall is not just for Earth. Free fall is taking place within and over the surface of any celestial object. Right. So we have David Scott's demonstration, David Scott experiment on the surface of moon. Let me, and I summarize the David Scott's demonstration regarding the free fall. Let me read the steps for this demonstration for you. David Scott simultaneously released a hammer and a feather on the same height, from the same height, same height above the moon's surface, above the lunar surface. So what did David Scott do in 1971? He released two objects with different masses. He released the feather, is a very light object, and hammer, very massive object actually, simultaneously on the surface of moon. So what did he observe? The second step, he observed that the hammer and feather both fell straight down and landed on the lunar surface. Lunar surface means surface of moon, and at exactly the same amount, the same moment. So both of feather and hammer, regardless of their masses, uh, landed on the surface of moon at the same moment, by the same velocity, by the same acceleration. Right. The last explanation for David Scott demonstration, both objects fell at the same rate. Means both objects, feather and hammer, fell at the same velocity, and they traveled the same displacement in the same amount of time. So what does this note actually talk about? It talks about the objects, I told you, regardless of their masses, heavy object like hammer and light object like feather, they travel the same distance vertically downward, and they move side by side. And this is, I can say, this is the first confirmation of Galileo's thought. In previous year, actually we got information about the Galileo's thought versus actually Aristotle's thought. Aristotle focused on mass, and he believed that the uh, actually massive objects fall faster than lighter one. Heavy objects fall faster than lighter one. But Galileo refused this thinking, and he said, in the absence of friction, all objects, regardless of their masses, whether they are heavy or light, they get the same velocity, they travel the same displacement, they get the same acceleration, and they fall down on the surface of any planet simultaneously. This is the thinking of Galileo, and this experiment or this demonstration for David Scott was the first confirmation of Galileo's thought. Right. So there are, guys, I'm gonna finish the lesson here. I leave the property of free fall for the next lecture, for the next lesson. I want you to follow our next videos, and bye-bye.